welcome back. We're going to look at graphing polynomials in factored form. Okay, we're going to work at graphing polynomials when they're in factored form. So let's start with just one that we've already sort of should know how to do. We looked at it in the last section, which is just graphing a quadratic. We know how to do that, I hope. Not, then this is another chance to figure it out, right? So let's take y equals, let's say x minus 3, x plus 5. Okay, so if I wanted to graph this, it wouldn't take too much. Okay, I would go, I know that there's a root at 3. Okay, and there's also going to be a root or a 0 at -5. Okay, and I know it's a parabola that goes up, right? So I know that it's going to be like so. And that's pretty much all I need to know for right now. Okay. Okay. Now, there's two other ways that we're going to look at how I could graph this. Now, for this situation, I don't need these two other ways because, well, as you can see, we just graphed it. Okay, but I want to show you these things because these techniques will help you on the next set of problems. Okay, so as these problems get a little more involved. Okay, so the first technique, and you can use either one of these. We're going to start with the end behavior. Okay, what is the end behavior here? Well, the end behavior is you would multiply out the leading terms. So our y, and I'm going to write it like x squared. Okay, and I'm using this little sign to mean it's not really x squared. It's just as x is huge, the x squared is the leading behavior, right? And I know what that looks like. So I'm going to put it in there. Second, I'm going to look at my zeros. Okay, my zeros are going to be at x equals 3, x equals -5, and they're both multiplicity 1. Okay, now I'm going to start graphing. Now I'm just getting the same graph that I got before, so it shouldn't be surprising, but we're just getting it a different way. Okay, so what's happening is I'm going to start with my end behavior. So my end behavior is going to tell me what the endpoint should look like. So that means I should start out up here. Okay, my zeros at at -5 and +3 are there, and it should cross at both zeros. So if I start out up here, cross at -5, and then I have to turn around to cross at 3 again. Okay, similar graph. The only reason it didn't is because I didn't want to draw through my writing, but it looks pretty much the same. That's the first method of graphing these things. Move this over. Second method is what I call the sign chart. Okay. Sign chart is I take the different pieces. I have two pieces or two factors. I have x minus 3, x plus 5, and I'm going to put the roots in order. Okay, so my roots in order are -5 and 3. And then I'm going to put the factors along the left side. So what are my factors? X minus 3, x plus 5. Those don't have to be in order. Okay, then I'm going to draw little dashed lines there underneath. Now, x minus 3, that is the factor that gives you a root at 3. Okay, so I'm going to draw that in with a little closed circle there. X plus 5, that is a factor that gives you a root at negative 5. Okay, now, x minus 3. We remember what that does at its 0, right? I like to think of this, if you go back to our picture, this was a line sloping up. So a line sloping up always changes from being negative to being positive. X minus 3 is a line sloping up. So at its 0, it changes, from being negative to being positive. Okay, so at its 0, it changes from being negative to positive. X plus 5. This is also a line sloping up. The slope here is, remember, the coefficient of the x. So it's 1 in both these cases. So it is also going to be negative to positive. Okay? So now, remember, when you multiply, there we go. Knew something didn't feel right. I had that one should be a plus, not a minus. So now, when you have two negative signs together, that gives you a positive number, right? When you multiply two negative numbers together, that gives you a positive number. When you multiply a positive and a negative together, that gives you a negative number. And when you multiply two positives together, that gives you a positive. So now, before negative 5, your graph should be positive. Between negative 5 and and 3, your graph should be negative. And then after 3, your graph should be positive. Okay, so for this problem, we didn't need all this machinery, right? And that's fine. But I wanted to show you these methods because they're going to work better when you have, or they're actually what you're going to do. Ooh, that's ugly. There we go. Okay, so the benefits of these are the sign chart, while it may be a little harder for some people, okay, once you get it, it is super fast. Okay, it's super fast and it's hard to screw up once you get it. This method is fine, it is, okay, but this method requires you graph the function, okay? For a lot of things, for example, inequalities that we're going to do later on, the sign chart doesn't require you to graph things, okay? You can just do the sign chart and you can understand what's going on. So there are benefits to both, okay? I would suggest trying both to see how they all work out for you, okay? Let's do a problem. We're going to do it both ways. So let's graph. Let's take y equals x minus 4, x plus 5, x minus 3 squared. Let's put in a 2 minus x just for the fun of it. That ought to do it, okay? So now, let's start, we're going to do it both ways. So let's start first. Let's take the end behavior. So end behavior, we're going to have x, x, x squared, so that's x to the fourth, minus x to the fifth. Okay, so that minus is gonna play around with us. So our end behavior is y equals minus x to the fifth. Okay, so what does our end behavior look like? Looks like so. Okay, so that's what it would look like if you were to zoom out. Okay, you can even play around with that. There's graphing calculators online. Go ahead and graph this and then zoom out and you'll see that it looks like this. Okay, just check 1, 2, 3, 4, negative 5. Yes. Okay, well, negative x to the fifth. Okay, next, let's take our zeros. Okay, our zeros are at x equals 4, x equals negative 5, x equals 3, x equals 2. And they all have, well, they all have multiplicity 1, except for that 0 at 3 that has a multiplicity of 2. Okay. Now we can go ahead and graph this thing. So, negative 5, 2, 3. Ah, wish I wouldn't put those numbers so close together. Oh well. Let's do this. Two, 3, 4. Okay, so I'm horrendously off scale on the left, on the right, but that's all right. Okay, so now it's going to be starting out up here. Okay, so starting out up here, it's going to cross at negative 5. At 2, multiplicity 1 again, so it crosses. At 3, we have a multiplicity 2, so it's going to take a bounce there. And then at 4, multiplicity 1, it's going to cross. If you did this correctly, which it seems like we did here, then our end behavior should match. We started with this end behavior, we end with the correct end behavior. Okay? Rises to the left, falls to the right. Okay? Let's take a look at this through the sign chart. I won't graph it, but I'll show you how you would have. Okay. So, again, we have zeros. Where are our zeros? 4, negative 5, 3, and 2. So our roots are at negative 5, 2, 3, and 4. Okay, move that up a little bit because I think it's, let's move that whole thing up, give me more space. Okay. Now, what are my zeros? My zeros are, I'm sorry, my factors are x minus 4, x plus 5, x minus 3 with a square on it, and 2 minus x. So, x minus 4, x plus 5, and we put x minus 3 squared, and 2 minus x. Okay. Notice I did have to pay attention to put those in order. Okay. X minus 4, that has a root at 4. So I'm going to put my dot there underneath the 4 across from the x minus 4. Underneath the negative 5 across from x plus 5. Underneath the 3 across from x minus 3 squared. And underneath the 2 across from 2 minus x. Okay. Now, x minus 4. This is a line that slopes up again, right? This is a line that slopes up, so it's going to go from negative to positive. Okay. X plus 5. That's a line, again, sloping up. The slope is 1. So just like the example I drew on the other page, it's going to slope from negative to positive. X minus 3 squared. X minus 3 squared, that's a square, right? So that means it's always positive. Except that it's 0 where it's 0, but otherwise it's positive. Now 2 minus x, that's the red herring here. That is a line, but it slopes down. So when it slopes down, that means how's it going to change, you think? That's right, it changes from positive to negative. Okay, so now, 2 negatives total gives you a positive. 1 negative total gives you negative. 2 negatives gives you positive, positive, negative. So what I want you to notice, before negative 5, it's positive. Between negative 5 and 2, it's negative. It's below the y-axis. Between 2 and 3, it's positive. Between 3 and 4, it's positive again. And then after 4, the whole thing is negative. Okay? All right, I'll be back with another one in just a minute.